Okay, so let's start our class. Okay, so in last class, we talked about the recursion method. We said that the recursion method is a method calls itself directly or indirectly. Okay, so, and we also talk about how to write a recursive definition for the factorial number. And then we also talk about how to implement the recursive method to calculate the factorial number, and we did some exercise. Okay, so in today's class, we will working on the other problem that can be solved using factorial, using the recursive easily. Okay, so we will talk about how to get a Fibonacci number. Okay, so the Fibonacci number by the definition is the first Fibonacci number is 0 and here I means is index, okay, and the second Fibonacci number is 1, and the rest of the Fibonacci number will be the sum of the previous two numbers. Okay, so a Fibonacci number equal to the sum of the previous two numbers. Okay, so let's give you the example. So for example, I have this Fibonacci sequence. Okay, so Fibonacci sequence, the first number is 0, the second number is 1. That is our base case. The next number will be the sum of the previous number. Okay, so the third number will be sum of this one, that will be 1. The next number will be sum of these two, that will be 2. And the next number will be sum of the previous two number, that will be 3. The next number will be sum of these two, that will be 5. And the next number will be 8. And the next number will be 13. And the next number will be 21st, 21, and so on. Okay, so this is how we calculate the Fibonacci number. Okay, so and we also in the Fibonacci number, they already by the definition, it's already defined recursively. Okay, so now let's see how to implement this one. Okay, so first let's start our class. I will call this is chapter 18-2. Okay, so public static void main, we using the main methods later on for the testings. Okay, and now let's okay, define this Fibonacci number. Okay, this Fibonacci number let's return along. Okay, let's call this is Fib. Has give you the n. I would like to find out the nth Fibonacci number. Okay, so for the nth Fibonacci number, remember we talk about then we talk about the if we try to write a recursive method, we first need the base case. Since the recursive method means the method call itself. Okay, so if you don't have if you didn't stop the program at some point, this call will be running forever. Okay, so which is means we for recursive method, you always need to have a base case. This base case will guarantee your program will stop at some point. So, okay, so now let's call this one. Okay, let's call this is I want to find the user index. Okay, for example, this is our Fibonacci sequence. The index for this one is 0, is 1, is 2, is 3. It's 4, it's 5, it's 6, it's 7, and it's 8. Okay, this is a index. Okay, so when we create this method, I give the index. I want to find the for example, eighth Fibonacci number. What is eighth Fibonacci number? So, if the base case as the definition tells you, if the index is 0 and 1, 0 is 0, 1 is 1. Okay, so the base case will be if the index equal to 0, this one will be return 0 because the first Fibonacci number is 0, and if the index equal to 1, this one will be return 1. And then we need, for the rest, we need this recursive call. Okay, recursive call will be the Fibonacci, the index Fibonacci number will be the Fibonacci numbers, the sum of the previous two Fibonacci numbers. Okay, index minus 1 and plus Fibonacci number index minus 2. Okay, so index minus 2. Okay, so this is how we implement the Fibonacci number. Okay, so now let's testing. Okay, so remember, keep in mind the Fibonacci number definition, recursive definition like this. If the index is 0, that's the number is 0. If the index is 1, that is 1. The rest of the Fibonacci number will be sum of previous two numbers. Sum of the previous two numbers. And so like this one. Okay, so next one will be 34. Okay, so this one will be our nice Fibonacci number. Okay, so and when we write the code, okay, Fibonacci number, and if the index is 0, the number is 0. If index is 1, that is 1, and the next number, the index, the number, this index number will be the sum of the previous two numbers. Now let's testing it. Okay, so system.out.println, and now let's see Fib 9. Okay, Fib 9, I expect this will be return 34. Okay, so let's comment this one. Okay, so yeah, let's compile and let's run it. Okay, good, we got the correct answer. Okay, so this is how we calculate the Fibonacci number. Okay, so now let's back to the slides to see some detail. Okay. Okay, now you can see to calculate the Fibonacci number. Okay, the Fibonacci number's definition is like this. Okay, so if the index is 0, that is 0. If the index is 1, that is 1. And then the rest will be if the index is greater or equal to 2, and the Fibonacci number will be sum of the previous two numbers. Okay, so okay, so now let's see how can we actually how these methods will be work. Okay, so for example, if we are trying to calculate the Fibonacci 4, remember, since 4 is greater or equal to 2, then this should be the Fibonacci 4 will be the sum of the Fibonacci 3 plus Fibonacci 2. Okay, so and the Fibonacci, to calculate this one, we need to call the Fibonacci 3. The Fibonacci 3 is Fibonacci 2 plus Fibonacci 1. To calculate Fibonacci 2, the Fibonacci 2 is Fibonacci 1 plus Fibonacci 0. Since Fibonacci 1 index is 1, this will be return a value of 1. This one will be return value of 0. So this whole thing will be return 1. Okay, this one will be, let me make the drawing here. Okay, so this one, Fibonacci 1 returns 1, Fibonacci 0 returns 0, and 1 plus 0, this is 1. Okay, this is 1. This one will be, so Fibonacci 2 is 1. Fibonacci 1, that will return 1. 1 plus 1, this is 2. Okay, so then Fibonacci 3 is 2. Okay, so and then we calculate the Fibonacci 2. Fibonacci 2 equal to the Fibonacci 1 plus Fibonacci 0. Fibonacci 1 is 1, Fibonacci 0 is 0, so this one will be return 1. So then we can see Fibonacci 4 will be 2 plus 3, 2 plus 1, that is 3. Okay, so let me erase this part. Okay, so now you can see to calculate Fibonacci 4, we need call this Fibonacci 3 plus Fibonacci 2. To calculate Fibonacci 3, we need to do this. And to calculate this one, we need to do this all the way. Okay, so in this case, let's see. If we are trying to calculate the Fibonacci 4, and we need a call, how many Fibonacci calls we need? Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that is 8. We need 8 Fibonacci calls. Okay, now let's back to the okay. Cool. Okay, so the first question is the homework. First question is I may ask you how many times is a Fib method invoked for the Fibonacci 6. Okay, so what I want you to do is you need to draw the picture like this and to calculate if we are calling is a Fibonacci 6. How many Fibonacci calls you need? Okay, to calculate the Fibonacci 4, we need a 1, 2, 3, 4, 5, 6, 7, 8 with like 8 Fibonacci calls. If it's Fibonacci 6, how many calls required? Okay, so and also you might already see this. And to calculate the Fibonacci 4, we have to make this 8 Fibonacci calls. And for Fibonacci 3 called once, 2 we called 1, 2 times. 1 we called Fibonacci 1 we called 3 times. Fibonacci 0 we called 2 times. And there do have some redundancy, right? Okay, so let's back to the code. Okay, so this is your first homework. We ask you to draw the picture and show how many calls you need for the Fibonacci call. Okay, so and you may see that that is definitely this one is not very efficient because we calculate Fibonacci 4, for example, we need to make 8 Fibonacci calls. Okay, so this is also could be implemented using a iterative method, which is means using a this is a recursive method for to calculate the Fibonacci number. Okay, so the next homework we need to ask you to do is we ask you to implement a iterative method for the Fibonacci call. Okay, so okay, so now let's working on the other example. Okay. And actually, let's first give you guys some idea how to implement the Fibonacci call using the iterative methods. Okay, so now let's we ask you to implement the Fibonacci. We call this is iterative methods. Okay, so we give you the index. Okay, so for this one is we need to remember we said the Fibonacci number is we know the first Fibonacci number, which is 0, and we know the second Fibonacci number, which is 1. Okay, so now we ask you to see the what is the ith Fibonacci number. Okay, so give the index. Okay, so this one is we know the Fibonacci number equal to Fi equal to the sum of the previous 2 numbers. Okay, so now let's see. We can start from the since we already know the 1, 0, and 1, so we start from the 2, and if the I less than the index and the I plus plus. Okay, so and we know the Fibonacci, the ith Fibonacci number will be equal to the sum of the previous two numbers, right? Okay, and after you sum this one, okay, we need to update the previous number. Okay, so the F0 will be, so let's give you here. Okay, so if we trying to calculate this one, this F2 equal to F1 plus F0. Okay, so now if we calculate the F3 will be this one plus this one. Okay, so we will update the F0 to this one, F1 to this one. Okay, to the previous two numbers. Okay, so F0 will be F1 and F1 will be the previously Fi. Okay, so that is how we using the iteration. Okay, then we can return Fi. This Fi will be the, this is how we using the iterative using the loop to find out the Fibonacci, the ith Fibonacci number. Okay, so now let's testing that in here. Okay, so let's see, let's copy this one. Okay, so we using this iterative. Okay, so make sure, iterative. Okay, let's run it. So when you run, you can see, we got the correct answer. So now you may see, I think this one is much easier because it's very straightforward. It's just as how it defined. This one, it take a little bit of effort. Okay, so let's try something. Okay, so for example, if I'm trying to, let me first comment this one. Okay, if I'm trying to calculate the Fibonacci, let's see, 20. Okay, let's run it. Okay, that is Fibonacci 20. Let's try Fibonacci 40. Okay, so let's run it. You may see it's take a little bit of while, right? Let me try the Fibonacci. My computer is pretty fast, so we cannot see the. Okay, so you can see it's take a pretty long time. It's still running, right? It's still run. Okay, so let's wait. Okay, I guess it's at least several minutes, several seconds already passed, but we still didn't got the results yet. Okay, now let's stop it because it takes too long. Okay, but if I'm using the iterative to calculate the 100th Fibonacci number, let's see how long it will be take. 100. When you run, okay, you got the, since this is 100 is too large because it's already exceed the, let me see, make sure, it's exceed, this one should, I should define this as a long. You can see this is a int is not enough for a 100th Fibonacci number. This is already overflowed. Okay, so I change this to long. Okay, so let's make all of this too long since it's it's a little bit later that will be. Okay, so now let's run it. You can see that is a real number, 800th Fibonacci number. Okay, now you might notice that using the iteration is much efficient than using this recursion method. Why? Remember we talk about if we have if we have 4, if we call the Fibonacci 4, we need 8 Fibonacci calls. There has a lot of redundancy. But if we using the iteration, that will be much faster. Okay, this will be much faster. So now you can think about it. Okay, so every time when the problem is coming, if this problem can be solved using the recursion, there must be a way you can solve this problem using the iteration. Okay, so you need to get the trade-off. Make sure you sometimes the recursion method will cause some redundancy. Okay, so okay, so that is the first. This is for the Fibonacci number. Okay, so and this is our first homework. The second homework will be, I will ask you to write a program, okay, to compute the greatest common divisor, okay? We call this the greatest common divisor using the recursion, okay? So let's first see what is a common divisor. For example, greatest common divisor. Okay, so for example, I have a number 12 and I have another number 3. Okay, so greatest common divisor will be 3. Okay, if I have a 20 and 18, so here, let me write here. The greatest common divisor is 3. If I have two number 12 and 18, let's see, the greatest common divisor will be 6. Yeah, because 12 divided by 6, which is 2, 13 divided by 6, which is 3. Okay, so that is how you find out the greatest common divisor. Okay, so yeah, we ask you to write compute the greatest common divisor using the recursion. And so for example, give you two numbers m and n. You need to define this GCD, this method. Okay, to find this one, this method will be return the greatest common divisor for the m and n. So this is this greatest common divisor recursively definition will be if m mod n, if m mod n is 0, then the greatest common divisor will be n. Okay, so like this case, since 12 divided by 3 is 4, so the remainder is 0, so which is means 3 will be the greatest common divisor. Okay, so if it's not otherwise, okay, otherwise what will be the commonest divisor? Okay, so then we need to we expect the m is greater than n. Okay, m is greater than n. So this one will be otherwise this one will be greatest common divisor n m mod n. Okay, so let's using which one is, let's using this one as an example. Okay, so if I have these two numbers, I'm trying to calculate the greatest common divisor between m and n. So since 12 mod 8 is not equal to 0. Okay, since it's not equal to 0, then what we need to do, and we need to find out the 12 mod 8, which is 4. Okay, so which is 4. Then we got n here and m mod 4, which is here. Okay, then we will be call this one GCD, and we calculate the then we now this time is 8 mod 4, which is 0. So the common for this problem, the greatest common divisor, this one will be return 4. Greatest common divisor is 4. Okay, so this is a question. This is one of your question after the class. Okay, so okay, so let me see. Okay, sorry. Okay, I'll slow down. Okay. Okay, so then we can let's working on the other problem. Okay, so okay, so this time we will be find the check is a string palindrome. Okay, let me write down this here. Okay, so the next methods will be okay, check if a string is is a palindrome. Okay, what the palindrome means? Okay, so for example, mom, this is a palindrome because if you read from left to right, that is MOM. If you read backwards, okay, from right to left, it's also MOM. And like the race car, okay, yeah, race car, this is a palindrome since if you read this string from left to right, that will be RACECAR. If you read this backwards, it's also RACECAR. So this is a palindrome. Okay, so and like another example, like the gnome, that is a palindrome. But for example, like the string, this is not. Why? Because that is you read from left to right, that is different from the right to left. Okay, this is not. Okay, so we now let's see, we can let's think about it, how to implement, give it a string, how to check if this string is a palindrome or not. Okay, so now let's first write the iterative method for this problem. Okay, so we call this is a public static boolean. This one will be, I call this is a iterative check palindrome. Okay, palindrome. Okay, so pass a string s. Let me make this a little bit smaller. Okay, so oops, it's too big. Make this smaller. Okay. Okay, so now let's see. If we trying to check that iteratively, okay, so give you a string, I will check the first letter with the last letter. If the first letter is equal to the last letter, oh, let's ignore the space in between. Okay, so if the first letter is equal to the last letter, then we move to the next one. Okay, the first one will increase one, index will increase one. The second will, the last will be decrease one. Okay, then we check if this one equal to this one. Okay, if yes, then we check keep continue until we only have one left, or until our low index is greater than the high index. Okay, so that is for example, if the string, if we check the first one is not equal to the last one, we immediately know this is not this string is not a palindrome, right? Okay, so what we can do is first let's have has a Boolean variable called is a palindrome. Let's first initially make this as a true. Okay, so and we need the two index. At the very beginning, your low index will be the index for the left side. Okay, and at the beginning, your high index, I use the high index to check the last index. Okay, so the high index will be your string length, and the -1. Oops, and the -1. Okay, this is the index for the low and high. Okay, so then we write this while loop. As long as while the low is less than the high, if the low index, the low index is in the left side, the high index is the right side. As long as the low index is less than high index, what we need to do, and we need to check. Okay, we need to check this for the strings character at the low index. We check if this one is not equal to the character in the high index. Okay, so if this one is low, the character in the low index is not equal to the character in the high index, we immediately know this is this palette. Yeah, let's just make this return false. Okay, we know this one is we know this string is not a palindrome. Okay, so else what we need to do, if it's equal, and if this one, for example, if this one equal to this one, we need to check the next one. Okay, so then this time, and we need to for our index of low, we need to increase the index, we need to go to the next one. For the low, for the high, we need to go to the previous one, and we keep checking all the way. Okay, we keep checking. Okay, so then if you didn't return from here, okay, if you didn't return from here, you know, and return true. Okay, so we know this string is a palindrome. Okay, so this is how we implement this check a string is a palindrome using the iteration. Okay, so now let's testing our program. Okay, so go back to here. Okay, system.out.println, and I using this iterative. Let me copy this here. I don't want it's too long. Okay, so the method is the name is pretty long. Okay, so now let's giving the string. Okay, I giving a race car. I expect this will be returned true. Okay, so let's run it, and you can see, yeah, this is a palindrome. Okay, so now let's try another one. If I try this to add B, C here, BD here. Okay, now I expect this one will be return or false. Let's run it. Okay, now this is not a palindrome. Okay, so this is how we, let me slowly go through this again with you guys. Okay, give you a string. If we trying to check in this string is a palindrome or not. Okay, so we need to have first we need to have two index. The low index point to the left side of the string. The high index point to the end of the string, and then we check if the string, if the character in here equal to here, we go to check the next one. Okay, if the character is here is not equal to here, then we immediately know this is not a palindrome string. Okay, so this is how we implement the palindrome string using iteration. Okay, so now let's see, let's talk about how to implement using a recursive method to check if the string is to check the string is a palindrome or not. Okay, so let's think about using the this is a string I passed. Okay, so if I check this, if this two is the same, now the substring of this is a substring. I can call this check the palindrome again. So that is how we we use this as a new string, and we check if this string is a palindrome or not. Then we've always checked if the first is not equal, that will be return false. Otherwise, we will check the substring and keep going until we only have one left. Okay, so Okay, so now let's go to here to, yeah, let's implement this method. Okay, so we call this is recursive check palindrome. Okay, give you the string of S. Okay, so what we can do is, yeah, first let's talk about, since we are trying to use using the recursive method. Okay, so the base case number one. Okay, so if the string only contain one letter, okay, it's only contain one character. Okay, of course that will be returned true, because if it's only one, no matter you read from left to right or read from right to left, it's always a palindrome, right? Okay, that is the base case one. Okay, now let's see base case two. Base case two, which is means if the first letter is not equal same as the last letter, we immediately know, yeah, we immediately know this is not a, so if the first character is not same as the last character, and we immediately know this is not a palindrome string. Okay, so okay, so based on this, otherwise we can, so for the recursive call is we will check the substring. Okay, so let's write the code here. So, okay, if your string only contains string length less or equal to 1, okay, we immediately know this string is a palindrome. Okay, so else if what? If the string's first character, okay, is not equal to this string's last character. Okay, so s dot length -1. Okay, so if this one, we immediately know this is not a palindrome string. Okay, so then what we need to do? Okay, so else we need to return, we need to got the substring and check if this substring is a palindrome. Okay, so okay, so else we need to call for the S, we will find out it's a substring. Okay, the substring will be, okay, so like in this case, like in this race car, the substring will be this part. Since we already checked the first and the last, right? This will be, we need to got the substring. Okay, so the substring will be start from the index of 1 and end from the right here. Okay, s dot length -1. Okay, yeah. Okay, now let's review this again. Okay, so if we're using a recursion to check the palindrome, okay, we have two base case. If your string only contains one letter, yes, if it only contains one letter, yes, this string is a palindrome. If your second base case is if the string first character is not equal to the last character, no, this is not a palindrome. Otherwise, we check if the first letter equal to the last letter, then we can check the substring. Okay, we can check the substring like we just shows you. Okay, so we check with the first letter equal to the last letter. Okay, so then we check the substring. Then we check this substring. Okay, check if this substring is a palindrome or not. Okay, so that is how we did this. This program is right here. Okay, so now let's testing our program. Control C and go into your main methods. Okay, go to your main methods. Let's testing it. Okay, so system.out.println and we need to call this recursive check palindrome. Let's see. And if I give the race car, okay. Yeah, I miss one. Okay, so let me see. Recursive call is right here. Yes. Okay, so this one, instead of using an iterative call, I use this recursive call. Let's try. I expect this will be return me a true value. Okay, that will be return true. If I change this, like add another AA. Okay, now this one will be return false. Now you can see. Okay, so this is how we using the iteration to check the string is a palindrome or not. This is how we using the iteration. Okay, so okay, so now let's working on the other problem. Okay, now let's see in this in this question. Okay, so in here, if we define this recursive method to check the palindrome, and you probably already noticed that we always need to pass this string as a parameter. That's which means every time when we use these substring methods, this one will be return a copy of this one will be return a substring, so that will be not very efficient. Okay, so we might want to make, since the string is already there, okay, we don't need got the copy of the substring. Okay, so now let's working using a more efficient way. Instead of using a whole string, we only keep the one copy of the string. Okay. Okay, so I call this is I can okay, recursive methods, not just using the substring, we can only define the recursive method with the string index. Okay, so let me show you how can we do that. Okay, so public static boolean, and I'm trying to use this recursive check palindrome, but this is my second version. Okay, so give you this time what I'm trying to I give you the string, and in the same time I also give you the index of the low and high. Okay, I pass this as one of the parameter. Okay, so now what we can do is remember for the base case, and we said, okay, if the low is if the index in the left side is greater than index in the right side. Okay, so this one, which or less or equal, which means or you only have one letter in your string, which means yes, if I only have one letter in my string is a palindrome. Okay, so the second case is base case, remember as previously. So else if what? Else if my strings character in the very beginning, okay, in this case, my very beginning is my low is not equal to the character in the at end of my string. So if this happens, which is means yes, I know this is not a palindrome. So otherwise, okay, otherwise what we can do, we can return, okay, we can return, let me copy this part. Yeah, actually, let me copy it. Okay, let me, I call this string and I make my low index plus plus and make my high index minus minus. Okay, so let's make this is your new low will be low plus 1. Your new high will be high minus 1. Okay, so that is how we instead of every time pass a string as a parameter. Okay, so pass a substring as a parameter for the methods. We just keep the same string. We keep the same string. We just change the low and high index. Okay, so now let's see how it works. Okay, so let's make sure it works. Okay, going to your main methods. Going to your main method. Let me copy this one here. Okay, since I made this method is palindrome 2, and let me see. I'm trying to check this. I expect this will be return or true. Okay. Oops. Let me see what I did. Yeah, probably the file name is not correct. Let me copy this here. Okay, so sorry. This is a string, and my low in the very beginning is 0, and my high is let me. Okay. I need to give these ones length dot length minus 1. So let me put this right here. Okay, remember this, the second method, the recursive method to check the string is palindrome or not, is we pass a string, we pass the low index, and we pass the high index. The high index is always, the high index is a string's length minus 1. Okay, so okay, so that is let's run it. Okay, so yes, it is. Okay, so you may think about, every time someone make a call, I always need to, first time we need a call, this is always should be 0. This is a length minus 1. Okay, we can implement a helper. We can implement a helper methods. Okay, so going to this part. Okay, so let's get this, we call this is recursive help methods. Okay, recursive helper method. Okay, so this one will be, we will overload. Okay, this is a method overload. We will overload our methods right here. This is our methods, right? Okay. Okay, so we overload this method. Now this time the methods only have passed a string, and let's call this one. Okay, so this one will be, okay, this one will be returned. I pass a string, and at the very beginning, my low is always 0, and my high always the string's length minus 1. Okay, so these methods, you can see this is a method overloading. Okay, this method overloading means two methods, they have the same name but the different parameter list. In this one, I only have one string. This one, I have 3 parameters. Okay, so inside this one, I will call this method, and this method is then I will, since every time when we're trying to check the when we trying to check the this is this string palindrome or not, the low always start from 0 and the high always start from the length -1. Okay, so now let's go back to our, let's go back to here to testing it. Okay, so okay, this time, for example, what I just need is I don't need to get everything here. Okay, so now I just make a function call. This is we are trying to call in the helper methods. Okay, so when we run it, and then you can see this one will, oops, what did I miss? Yeah, I missed one parenthesis. Yeah, because this parenthesis match to the methods, this parenthesis match to the print line. Okay. Okay, that is true. Okay, this is how we using the this is how we develop the this helper method for our for these recursive methods. Okay, so okay, any questions so far? Okay.
Excuse me, I'm trying to see the helper methods.
What did you say?
On the last one you just did, the helper methods. Can you scroll down? Yeah.
You mean the helper methods here?
Yes.
Okay.
You used which one did you use in the brackets, in the parentheses? And you know the S, comma 0, comma. Is it that you don't have to, like, I don't understand this.
Oh, this part? Okay.
Yes.
Yeah, remember when we trying to using, when we trying to in the previously, okay, if we try to check if this string, okay, let me back to very beginning here. Okay, so let's go to this string. Okay, so if we are trying to using a recursive method to check if this is a palindrome or not. Okay, so recursive here. If there is only one string, it's okay. If it's not, the first one is not equal to the last one, it's false. Okay, so otherwise, if this one, if the first one is equal to, if this one is equal to that one, same, and then this one, this new substring will be using as a string to we will pass this substring as a parameter to check if this substring is a palindrome or not, right? If this substring is not a palindrome, which means the whole string is not palindrome, right? Okay, so the problem for using these methods is every times you need to find you need to generate a substring, right? This one will return a substring. This is not very efficient. Okay, every times you always generate. Let me write down this here. Okay, so for example, if I'm using race car as example, okay, when the first call we get to here, and then they need to generate a substring and make a function call again. They have to got this okay, let me see, I missed something, right? Race car, let me make this one. Okay, so this is a substring, and the next time, and I have to generate a substring, and next time until we get to here. So which is means in this program, your program will need to take the space to save this one, to take the memory for this one, take the memory for this one, take the memory for this one, right? So which is that's why this method is not very efficient, because you generate a full copy of the string and its substring. That's why this is not very efficient. So what we need to do, and what we improve this method by, instead of return the whole string, we just keep the same string, we just keep updating its index. Okay, we keep updating its index. Okay, so for this case is when we pass a string, okay, for example, in this case, when we pass this one, the low index is 0, we compare 0 with 0, 1, 2, 3, 4, 5, 6 with 6, okay? So then we pass the string and we pass this to in the low and high index, okay, since it's equal. And now the next time we keep the, let me got the another one, okay, so let me copy this here. Okay, for this case, okay. For this case, okay, so the first time I pass a string and its index. Okay, so the next time I don't need to make the copy of the string. I just pass its index. I compare the letter in the index 1 with the letter in the index of 5. Okay, so next time I don't need to make a copy of the string. I need only pass the index to compare 4, 2 with 4, compare 3 with, compare, since 3 is, I only have this one letter left. My string only have one letter, which means this string is true. That's all. So this one is much efficient. That's why we have this high and low. We pass the index of the string instead of always pass the substring as a parameter for the methods. Okay, so did this answer your question?
Yes, ma'am. Thank you.
Okay, so and also, and since we know every time when we trying to check, my starting low always 0, my starting high always length -1. That's why I have this recursive, I have this helper method. You can see this helper method has the same name and this one. Yes, this called the method overloading. And every time I just need to call this one, and this one will be call 0 and with string with 0 and the length -1. Okay. Okay, so any questions so far? Okay, so anybody need me to help you to debug your code? Okay, so okay, thank you. Let me back to the PowerPoint. Let's go through this. Okay, so we talk about how to find the palindrome, right? And you always need to think recursively. We know how to using the while loop, using the iteration to check if the string is a palindrome or not. Now let's think about think recursively. Okay, okay, so we check if this string is a palindrome. If it's only one letter, true. If it's a first letter is not equal to last letter, that is false. And then we use the substring. That is what we did. Okay, so then we talk about using the index instead of using we use the index as a parameter instead of always make copy of the substring of S. Okay, so then we also add these recursive helper methods. Okay, so yeah, okay, so okay. Okay, so any questions so far?
Hello?
Yes.
Yeah, I don't know what it is, but I didn't really understand that last part. Can you try and explain it again, please?
Sure. Okay, let me back to the code. Wait a second. Yeah, right here. Which part you don't? This part?
No, the slide that you just showed.
Oh, slides. Okay, let me back to the slide.
The slide was about the last line you just wrote. This slide right here, is it about the last line of code that you just wrote or the code before that?
This slide is just a code I wrote in the JGrasp.
Yeah, but you see how you have the palindrome,
Mm.
and you're talking about the last code that you just did, right? Where you minus one, you minus the one off,
Mm-hmm. Yes, yes. Yeah,
and then it becomes 5, and the other one becomes 2.
yes. Mm-hmm.
That's what you're talking about, right?
Yes.
All right. Thank you.
Okay. Okay, so any other questions? Anybody need me to debug your code? We still have about 10 minutes left. So do you guys want to continue or you want to stop here now? Let's back to the code. Okay, yeah, I guess I need to give you guys a little bit. Okay, so
What about assignment?
okay, sure. Yeah, that's what I'm trying to say. Okay, so in the assignment, okay, I want you to implement a recursive method to compute the greatest common divisor for two integers. And this is the recursive definition, okay? This is to find the greatest common divisor using the this is a recursive definition, okay? Write the code trying to implement this method, okay? This is one for your homework. So what I want you to do is, okay, greatest common divisor, okay? So I want you to implement a public static methods, okay? Return an integer, greatest common divisor, and you pass two number, two integer, m and n, okay? Let me just make this return -1. You implement this on your own, okay? So I want you to implement these methods, and then I want you guys to go to the main method to testing your methods. Okay, so for example, yeah, I want you to testing your method. Okay, so greatest common divisor of, let's testing the 5 and 6. I expect this one will be return 6. And I want you to test 12 and let me see, 18. This one I expect that you will return 6 too. Okay, so that is what we ask you to do after the class. Okay.
This assignment due next Sunday?
No, it's this Sunday.
This Sunday.
Yeah, this Sunday.
Okay.
Mhm.
And
Oh.
do we just move it in the same lesson, like the same file?
Yes, you put that in the same file. Yeah, same lesson, same file. Okay, so let me back to our, okay, so wait a second. Let's back to this one. Okay, here. Okay, so how to submit that? Going to the going to this folder, chapter 18 folder, and lesson, you need to submit your lesson 1 from this assignment, and you need to submit what we did in this assignment. Okay, and after class I will be upload the video right here, so you can, if you miss something in between, you can go to check the video and working. Yeah, the video will be uploaded here. Yeah, this one. Yeah. Any questions so far?
I'm just gonna go back to the code. The last thing you wrote in the code.
Okay, sure. Oops, wrong one. Okay, so last, you mean here?
Yes.
Okay, yeah. Okay, I guess let me stop recording now, and I will leave some time for students if they need help. Okay, let me stop recording now.